Hello everyone, welcome to this introductory video on combinational logic. In this video, we will explore the fundamentals of combinational and sequential circuits. Let's begin. So, what exactly is combinational logic? In simple terms, combinational logic circuits are those where the outputs depend solely on the current inputs. These circuits do not have any memory of previous states. Think of it as a direct cause and effect relationship. The output is a function of the present inputs only. A key characteristic of combinational logic is that it has no memory elements. Let's delve into some key properties of combinational circuits. Firstly, the output is a function of the current inputs, meaning the output is determined only by the values of the inputs at any given time. Secondly, combinational circuits do not have any feedback paths. This means the output is not routed back as an input. Thirdly, they offer an instantaneous response. The output changes almost immediately when the inputs change. Mathematically, we can represent this as y equals function of a, b, c, and so on, where y is the output and a, b, c are the inputs. Now let's understand sequential logic. Sequential logic circuits are those where the outputs depend not only on the current inputs but also on the previous states, that is, memory. These circuits remember past events and use them to determine the current output. The key characteristic of sequential logic is that it has memory elements. Let's explore the key properties of sequential circuits. Firstly, the output is a function of both the inputs and the memory. This means the past history of the circuit affects its present output. Secondly, sequential circuits have feedback paths, where the output is fed back as an input. Thirdly, these circuits are clock-dependent. The changes in output occur at specific clock intervals. Mathematically, we can represent this as y equals function of x, q, where q is the current state, and q plus equals g of x, q, where q plus is the next state. Let's compare the key differences between combinational and sequential logic. Combinational logic has no memory elements, and its outputs change immediately without requiring a clock. On the other hand, sequential logic contains memory elements, and its outputs change with a clock signal, making a clock signal a requirement for its operation. Let's look at some common examples of combinational and sequential circuits. Examples of combinational circuits include logic gates, such as an OR, and NOT gates, multiplexers and decoders, and adders and comparators. Examples of sequential circuits include flip-flops and latches, counters and registers, and state machines. In summary, understanding the fundamental difference between combinational and sequential logic is essential for digital circuit design. Combinational circuits produce outputs based only on current inputs, while sequential circuits' outputs depend on both current inputs and memory. Up next, we will take a deep dive into combinational logic design principles. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.